Okay, guys, we are back at solving ACSL strings. And I'm doing the second intro problem from the introductory sample problems I gave you. And as you can see, I've moved the document. Actually, it's not a real doc cam. It's a makeshift one that I've kind of made up. And hopefully this will be a little better than that first problem that we did. I can tell the focus still isn't quite where we want it to be. But let's go ahead and see what we can do with this problem, see if it goes any better. Hopefully I can go through it a little quicker. It looks like a shorter problem. So we have a string A equal computer, and then we have two null strings. Remember the null strings we talked about? Whenever you have two quotes with nothing in between them, those are actually valid strings. We call them null strings. It's not a null in the sense of emptiness, like you'll learn about maybe in another programming class. Null just means you don't have a value where you should have a reference, but that's way ahead of things. But this is actually a null string, which means it's a string, but it has no characters. So it's actually, these are actually both B and E are both strings of length 1. Just two quotes next to each other. Then we got the null string. Okay, so they have length 0. Did I just say 1? Then we have a for loop here. This time it's an I loop, and I goes from 0 to the length of our A string, which is computer, less 2. Okay, so we're gonna figure out how long this is and subtract 2, and that's gonna be how many iterations we get from this. Well, with the off by 1 numbering anyway, the number of iterations that we'll have going through this A string here to create a B string. Okay, now there's some subtleties in this that we have to be constantly aware of as we progress through this, or we'll easily make careless logical errors that we don't want to make. Okay, so how long is computer? The length, so length, len of A is going to equal the number of characters in the string. So we got COM 3, PUT 6, 7, 8. There are 8 characters in the string, so it has a length of, length A, length of A returns an integer 8. And so we're saying for I equals 0 to the length of A, which is 8, minus 2. So it's really saying for I equal 0 to 6. Okay, now that's actually 7 iterations. Don't be fooled by that. We're going to iterate through this 7 times. Sorry about clearing my voice here, but okay, 0 to 6. They're going to be the numbers that we use, but there's 7 iterations there. Now, there's a subtlety here that you really need to notice. We are going to be concatenating the okay, first let's just look at this and review what I means. Okay, A subscript I means there's a range within the string that we're subscripting here. Okay, so we're looking at whatever the number I is. Well, it's 0 right now, so it's saying get all the characters from 0 through 0. The 0th character through the 0th character. So it really only wants 1 character. So that's an awkward way of telling us to just get 1 character. But that's what it is when you see doubles like that. And so what do we want? What is the 0th character of A? Well, if we look at the word computer, C-O-M-P-U-T-E-R, that's the value of our string. Okay. Well, the 0, since this is off by 1 numbering like C++ and Java, the 0 characters, that first one. So A sub 0, or even A sub 0 through 0, is just the C. Okay, and so the second one's going to be 1. The third one's going to be 2. The fourth one is going to be 3, 4, 5, 6, and then the R will be subscript 7, even though it's actually the 8th character in the string. Okay, but you know about that. You know about all that. Okay, so we want that C. What are we doing with that C? Well, B is going to be set equal to the C, now here's the really subtle part of this. You do not want to get burned on it. You do not want to get tricked by this. Okay, the other problem, we were just, when we did that other problem, let me pull that one back in here. Actually, it's on the other side. Forgive me for doing this. But when we did that previous problem in the other video, we were just concatenating. You can see this problem better now, can't you? Now that I pulled the camera back like I should have done in the first place. Okay, when we were building the X string as a result, I really want you to focus on this part right here. When we were building, when we would get true and we would build this X string from its previous value and then adding on the new A string character to it, we were adding the character to the right of what was already there. So coming down here, you know, we started with the U. That was our first character when we compared that U to the A. And it actually was greater than the A. So we said, okay, that qualifies, that starts our X string from null to U. When we did that, and you know, after that, any succeeding characters we would put to the right of the string, because that's what it told us here. It's subtle, but very clear that you add the new X string that you were building with this, please, with this assignment operator. Okay, forgive the background noise and I'll try to ignore it myself. Okay, it's just somebody having fun. We were adding the new character to the right of the old string. Now that's going to be different on the first part of this second problem. Okay, because it's telling us, again, this is subtle, please pay attention. It is telling us to take the new character, the A character at the ith position, okay, and to form the new B string, you know, with this assignment operator, maybe I should erase all this. To form that new B string, we are putting the A character to the left of the old B string and making that the new B string. That is very important because further down, you know, we're going to have to decide, oh, do we add the new string to the right or do we add it to the left? You know, what are we doing? Or are we completely replacing the string altogether if it's not concatenating to the old one? Those are the subtleties in this problem. It's a short problem, but it can be a tricky problem if you're rushing through it too quickly, okay? Which we're not going to do, but we're going to try and do it quickly enough that we don't make this into a really long video with lots of background noise. So we are here. Let's get the green pen. I equals 0. So we're looking at the 0th character, and we already determined that was a C. So what do we do with that C? We put it to the left of the current B string. Well, the current B string is what? It's just the null. So it's no big deal on this first. The whole B string is going to be C. So B goes from null to just C. Okay? So it didn't really matter left or right because it was just a null string before. But it's going to matter after this. So now we come to next I, which means I goes from 1. The step is implied to be positive 1 because there was no explicit step given. You know, step being the incrementation, we'll have that down here. Okay, this one will have a step of 2, but we don't have a step up here except the implied step, the default, which is positive 1. So I goes from 0 to 1. And what are we doing with that? Well, we're just going to say B, we're going to build on the B string. We're concatenating a new character from A back to B, but on its left side. Well, what is the 1:1? Okay, what is position 1? Well, since the off by 1 numbering says our subscript, 1 is going to be the second character in the string of string A, which is computer, and that's an O. Okay, that's the letter O. So what are we doing? Well, we're putting it to the left of the current B string, and the current B string is C, which means the next step here, B is going to be O on the left plus the old B string, which is a C. So we got O, C, and we are out of control. What else does O, C mean? Obsessive compulsive. Okay, that's what we are right now. Okay, and that's the 2 iterations of the I loop. Now, that should be enough information to tell you if you were going to write a comment for this uncommented, this poorly uncommented code, undocumented code, if you're going to write a comment for this and say, what is this doing? Well, this piece is taking our A string and spelling it backwards. Okay, now it's going 0 to 6. Is that going to be enough? We got to be careful because it might not take the whole string. So let's just make sure. All right. Well, we've done the 0 and the 1. We still have the 2, 3, 4, and 5 to do. So we need the not the second. Since 2 is actually the third character, we need the we still need to do 2, 3, 4, 5, and 6. Right. So we did 0 and 1. Then we did 2, 3, 4, 5, and 6. And those positions are actually the MP for 2 and 3, UT for 4 and 5, and E. So there's another trick in this problem. It isn't just spelling computer, and that's one of the common errors that people make in this when they try to do this problem, is they say, oh, I know what this is doing. It's spelling computer backwards. Well, no, it cut it short. Remember this? -2 instead of -1. We're off by 1, not off by 2. So this is actually spelling just the word compute backwards. The R gets lost. We won't have that. So as we continue with this, it's going to be B equal compute backwards. So COMPUTE is our B string without the R. If you carelessly put the R in there, then that's going to throw everything else off in the rest of the problem. Okay, any questions? 100 questions. Can't answer any of them, sorry. All right, because remember, this is just a recording. All right, so the next for loop here, oops, twisting it the wrong way. The next for loop here goes from here to here. It is also an I loop, but this I loop is done, so there's no overlap there. We're starting a whole new I loop. And so this one starts at 0 to length of B. Well, how long is B? 1, 2, 3, 4, 5, 6, 7. So B, length of B equals 7, the length of the B string, compute backwards, okay? And that's what we have here. So that's a 7. But a 7 minus 2, we got some extra stuff to think about here. Step 2. So what does this I loop really look like, this second I loop? It's going to be I equal 0 to 7 minus 2, step 2, which means I equals 0 to 5. It's going to iterate 6 times, but it's only going to iterate on the even numbers because step 2 means we skip 2 each time we iterate. So the first time it iterates, it's going to be I equals 0, and the next time it's going to be 2, and the next time it's going to be 4, and the next time it's 6, and that's out of the range. So it's only going to iterate 3 times for the values of I equals 0, 2, and 4. If we got that? That's what all this line up here means. Okay, so we're going to iterate for I equals 0, 2, and 4. Now, what the heck are we going to do with that?